Hey there peeps, welcome back to another math hit vid. And today we are going to be doing like a bunch of what type of numbers are all of these kind of problem and like how to do them and stuff. So our first question today is use the set of numbers shown to answer the question. So we have 6, 9, 15, 12, 21, and 25. So which describes this set of numbers. So right off the bat, we can do some exclusioning right here. So we've got odd numbers, which is definitely not right because 6 right off the bat is already not odd. Even numbers, because basically everything else but 6 is odd. And then we've got prime numbers, which is also definitely not true. Because right off the bat, 3 times 2 equals 6. So that means it does have some factors. So that means it's definitely not prime. So there's only one answer left. So it has to be D. And in a test, you probably don't want to go through every single one to make sure it's right. But right now it's technically not a test, so we can check it anyway. So we've got 2 times 3 equals 6. So 6 is check. 3 times 3 equals 9. Check. 3 times 5 equals 15, check. 3 times 7 equals 21, and 5 times 5 equals 25. So they are all composite. Do not do that in the test. You're going to take a lot of time off. Use the set of numbers shown to answer the question. So you got 1, 2, 3, and 6, which describes this set of numbers. And then again, we can do the right off the bat stuff again. So we've got prime numbers. No, because 6. Or multiples of 6, which is definitely not true because these are not bigger than 6. There's only the multiple of 6 is here, this one. And it's definitely not odd numbers because 6 again. So it has to be factors of 12. And then again, if all of your evidence, quote unquote, leads up to all of the other ones are wrong and then there's only one right, don't check them off again in the test because that's also going to consume quite a bit of time. But we can check them here because this is practice. So 1 times 12 equals 12. 2 times 6 equals 12. 3 times 4 equals 12. And 2 times 6 equals 12. So that means, yes, they are all factors of 12. All right, moving on. So question number 3. Use the set of numbers shown to answer the question. -5. -1, 0, 1, and 5. Alrighty. So, which describes this set of numbers? Integers, whole numbers, negative numbers, or prime numbers? And no, they're definitely not whole numbers because -5, -1. It can't be negative numbers because 1 and 5. And it can't be prime numbers because 0 is neither prime or composite. So 0 technically just doesn't count. And so that means that the only answer choice left is integers. But we can also check that out. So this is math vocabulary time, peeps. So integers are basically all the negatives that can be written like -1, -2, -3, and like 1, 2, 3, 4, and stuff like that, and a 0. So that means, yes, all of these are integers. And moving on, use the set of numbers shown to answer the question. 19, 29, 59, 79, and 89. Well, they all end in 9. No, that's not an answer choice. Which describes this set of numbers. So factors of 9, no, because none of them are smaller than 9, and none of them can be led up to 9. Multiples of 9, no, because right off the bat, 19 is not a multiple of 9. Prime numbers, we can check that if the last one isn't right, which it isn't, because irrational numbers are like pi. So it's like it leads on and on and on and on and on and on and on, and it's just forever. So these are definitely not leading on forever, so the only correct choice is C, pi. And I hope this vid helped, and I guess I'll see you guys in the next one. Bye!